Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about the types of vectors now. We've talked about equal vectors, we've talked about some of the introduction, but I think it's important before I start to solve, we should know the types of vectors because when I'm going to be solving, I'm going to be saying things like maybe zero vector, a unit vector, a position vector, a location vector, for instance, and I don't want anybody to be lost. So in this video, I'm going to list as many as I can. So the types of vectors and what they mean or what do they represent, okay? Before I proceed, don't forget to like, share, and subscribe. If you have any question, please don't forget to email me. And if you've not clicked the notification bell, I don't know what you're waiting for. Do click it so that when I post new videos, you'll be the first person to know. All right. So let me just remind you. So in the previous video, I told you a vector represented with an arrow, right? So we said the bottom here is a tail, and this is the arrowhead, okay? Then where it's facing is called the direction, okay? We talked about this, and I also told you that the size or the length is what we call the magnitude, right? So we talked about this earlier, all right? Now, in vectors, there are at least about 10 types. Okay, sometimes some textbook will tell you 15, some will tell you 16, but at least the ones that is really common, we have at least 10 types, but they are really, they're generally divided into two broad types. So we have the position vectors and the free vectors. In some cases, you will hear some things like the location vector, all right? So some people get confused, but I'm going to try to explain the difference between a position vector, a location vector, and a free vector, okay? Then I'm going to talk about other types of vector like zero vector, unit vector, equal vectors, negative vectors, parallel vectors, or maybe, for instance, co-initial vectors. I'm going to talk about all of them and give you definitions for them. All right, so because I know students do take note, I'm going to start writing now so that we can get straight to this, so that we can go back in the next video and we can then start solving, okay? I know we're all excited to solve, but I think it's important to make this background first, okay? All right, so let's start. So now, like I said, there are at least 10 types, okay? So there are at least 10 types of vector that are broadly divided into two. So there are at least 10 types of vectors. That are usually broadly divided into two. So the first one is what we call the position vector. All right. And the second one is the free vector. Now, for the position vector, okay, so the position vector represents the position of a point in space relative to a predefined set of coordinates, okay? So that is the position vector. While a location vector is when the magnitude and direction of that position vector can be changed relative to other bodies. That making sense? So a position vector is talking about the position of a point in space relative to a predefined set of coordinates. So that means if the set of coordinates is defined, that is a position vector. But if it's in relative to an other bodies or another vector, then that is the location what? Vector. All right, so I'm going to write it down. So a position vector, okay, represents the position of a point in space, okay, position of a point in space relative to a predefined set of coordinates. Okay, now this is a position vector. So this is the easy one. So when it's with the predefined sets of coordinates, it's called a what? A position vector. Now, but, okay, when the magnitude and direction of the position vector can be changed relative to other bodies, this is what we now call a location vector. So when the magnitude and direction of position vector all right, can be changed relative to other bodies. It is called location vector. Okay, so position vector represents the position of a point in space relative to a predefined set. But when that position vector can be changed relative to other body, is called location vector. So that is the main difference between a position. So that means technically you can say a location vector is a type of position vector. Okay, so you can say that. So it's like a subset of a position vector, but just that it is relative to other bodies. All right, so number two, the second vector. Remember I said broadly they are divided into two. So number one, the position vector, and number two is called the free vector. Okay, number two is called the free vector. Now, the free vector, this is not restricted in any way, all right? So it's not unlike position vectors where you have a point of predefined sets of coordinates or related to other bodies, but this is not restricted in any way. It is completely defined by its magnitude and direction and can be drawn by any one of the sets of equal length parallel lines. So there is no restriction unlike the position vector that is to a particular set of coordinates, but there is no restriction here. So a free vector is not restricted in any way. Okay? Basically, it is completely defined by its magnitude and direction. Okay? So it is not restricted, okay? And it's completely defined by its magnitude and direction and can be drawn. So, and can be drawn by anyone of a set of equal length parallel lines. Okay, so that's a free vector. All right, so basically from the word free, it is not restricted in what? In any way. All right, so those are the two broad types of vectors. So usually divided into these two broad vectors, either a position vector or a free vector. Now we're going to talk about the other types. So remember I said there are several other types. And I'm going to list them now. So the other types of vectors. So the first one, so we have order, all right? Well, other types of vectors. So the others include, so the first one we're going to talk about is the zero vector. So the zero vectors. So basically zero vectors, these are vectors that have zero magnitude, okay? So any vector that has zero magnitude is called a zero vector. So when we do some calculations and I ask you to find the magnitude and you found the magnitude to be zero, so that means those are zero vectors. So vectors that have zero magnitude. Okay. So number two is what we call the unit vector. So unit vectors, these are vectors that their magnitude is equal to 1. So when you solve and you found the magnitude of the vectors, okay, that you solved for, and the magnitude is equal to 1, then that's a unit vector. So these are vectors that have magnitude equal to 1. All right? Then the next one, number 3, is what we call equal vectors. I've talked about this a little bit in the previous video. So equal vectors. So equal vectors are vector with corresponding equal components. So remember in the previous video, I said equal vectors have the same magnitude and direction, or you can talk about it in terms of the coordinates. We'll talk about that later. So now, so two vectors are said to be equal if they have equal components. So equal vectors. So vectors with corresponding equal components. Okay. Number 4. The fourth one will be negative vectors. Negative vectors, these have same magnitude, but opposite direction, okay? So number 4, negative vectors. Negative vectors, they have same magnitude, but opposite direction. Number 5, the next one is called parallel vectors. So parallel vectors have same direction, but not necessarily same magnitude, okay? So this one has same direction, but not necessarily same magnitude. Okay, so same direction, but not necessarily what? The same magnitude. Okay, so push this a bit so we can have more space. All right, so we'll go to the next one, number 6. We're going to talk about orthogonal vectors. So orthogonal vectors, so the angle between the vectors are 90 degrees. or if you do the dot product of the vector is 0. All right, so I'm going to talk about dot product. I have a video in this series for dot product. And also have a video in this series on how to find the angle between vectors. Okay. But when you solve for the angles and you found out that the angle is 90 degrees, this is what we call orthogonal vectors. Okay. Orthogonal vectors. So the angle between the vectors are 90 degrees. Okay. Or the dot product. So I like to look at the angle or the dot product. So I'm going to talk about the dot product because in this video series, we talk about dot product, we talk about cross product. Okay, don't worry, we'll talk about that. But I just need to make this or list these types of vectors so that we'll all be conversant with the names and terminologies I'll be throwing around. Or the dot product of the vectors is what? Is 0. Okay, so the dot product of the vectors is 0. So number 6, so that's 6, right? So number 7, we're going to talk about co-initial vectors. So co-initial vectors are vectors that have the same initial point. So where the vectors are starting, if they are the same, the initial points are the same, is what we call a co-initial vectors. So number 7. So we have co-initial vectors. So these are vectors having the same initial point. So co-initial vectors are the vectors having the same initial point. Now the next one is going to be called coplanar vectors. So take this a bit up. That'll be number 8. So number 8 is the coplanar vectors. So the coplanar vectors, these are vectors that are lying in the same plane or parallel to the same plane, okay? So these are vectors that are lying in the same plane, okay? Or parallel to the same plane. Number 9, the next one we're going to talk about is the like and unlike vectors. So these are vectors in the same direction. So if the vectors are in the same direction, it's a like vector. But if this vector is in the opposite direction, it's an unlike vector. So that is number 9. So we have like and unlike vectors. Okay, like and unlike vectors. So vectors in the same direction are like. Or it's like vectors, okay? While vectors in the opposite direction are unlike. All right, so that's the main difference between both of them. So in the same direction, like, in different direction, in the opposite direction is unlike. All right, so we'll go to number 10. So remember I said in this video, we're gonna just talk about 10. But when you go to the textbook, you will find way more than this, okay? There are more than this, but we just talk about 10 because of based on what we're gonna be solving in this video. All right, so number 10 is what we call the displacement vector. So displacement vector, so basically, if a point A is displaced from another position A to B, okay? So if a point is displaced from a position A to B, then the displacement AB will represent the vector AB, so it will be known as the displacement vector. We'll talk about this down line, okay? So I'm just gonna introduce it here. Down the series, we're gonna talk about the concept of a displacement vector. But just to have it in your notes first for reference, so we just write it here. So if a point is displaced from position A to B, then the displacement AB represents a vector AB, because it moved from A to B, known as the displacement vector. All right. So this is the displacement vector, and that will be all for the 10 types that I will talk about here. All right. So, and also another thing for you to note is that most times, most of the vectors we'll consider here are going to be free vectors. So you have position, location, and free. And but these are the other 10 types of vectors. But you can talk about this. You can go to the textbook and check more. You'll see so many more than this, but I just selected this few so that we'll use it because we're going to talk about it down the line. All right. So now, I know you said, Terry, we will be talking a lot. Now, next video, we're going to talk about how do we add vectors, additional vectors. Okay. So additional vectors is the next video. So we're going to start calculating now. So make sure you subscribe so that when I post the next video on how to add vectors, you'll be the first person to know. All right, see you soon. And like I always say, if you have any question, don't hesitate to contact me. You can send me an email, or if you see me around, you can just stop me and I'll explain it to you. All right, see you soon.